Hello everyone, my name is Cherie Ledoux and I'd like to welcome you to today's webinar, Eyesight and Use for Underground. Your host today is Clayton Fritz. Clayton is a sales engineer for the Eyesight team in the Denver MapTech office. He offers assistance to both clients and prospects throughout North America. Today's webinar will conclude with a question and answer session, so please feel free to write in questions in the panel on the right-hand side of your screen. I'll now hand it over to Clayton.
Thanks, Cherie. Thanks, everybody, for joining us today. I want to take this opportunity to talk a little bit about the Eyesight 8200 Underground Scanner. We'll be getting into the software here in a minute and talk about how to utilize some of the existing tools and some of the new tools that have been added to Eyesight Studio to better process underground scan data. And the reason this has kind of come up is we've recently released an underground-specific scanner. So we've changed a few things. You may notice it looks very similar to our 8810 and even our 8400, but there are some unique differences that help it to be just specifically a little bit better for underground. The main difference is that the glass is actually curved so that you get a completely vertical scan. Basically what that means is rather than having an 80-degree scan window where you're missing a little bit of data above you, you can actually get full coverage of the back when you're scanning in a drift. Obviously, that's not been necessary with our OpenPit application, so that was a change that needed to happen. And several other things that we've added, including a new inclometer, which actually allows the software or the scanner to automatically correct a 90-degree scan that is scanned horizontally, which allows us to use a carbon fiber boom. And we've also added a 3D view of the scans on the tablet. So rather than just looking at all of the scan data from a plan view, you're able to look at them in 3D, which is definitely beneficial when you're underground since there is data on all sides. So let's talk about some of the underground applications and maybe some of the reasons that we developed the underground scanner. The big one that jumps out right away, stope surveys. Needing to get an accurate volumetrics of the stope itself and actually map it to see, how well it actually conformed to the design. And face mapping, geotechnical mapping. We've been doing this in OpenPit applications for a while, and all of the same tools are applicable for underground. And now that you're able to attach a third-party photo, lighting isn't necessarily an issue, and mapping of backs and development of drives and drifts and things like that. And we've kept a lot of the versatility from our OpenPit models, which even allows for surface stockpiles to be scanned and calculated. Here you can see a picture of our 8200 underground scanner fully extended on the carbon fiber boom. So that's one of the many uses for it. And here it is sitting up on a tripod. So it has a 200-meter range, and we wanted to keep a lot of the versatility. We've tried to approach this with the mindset of one scanner that can do everything that's necessary for an underground mine. Rather than just being able to scan drifts or just being able to do stopes, we really wanted to kind of make one tool that could do all jobs. So we've kind of come up with a few really unique options that can make it make it a little bit better suited for each individual job, including the carbon fiber boom, an IT mount, which allows you to actually mount it onto an IT basket or a front-end loader so that you can actually raise it to extend it out into a stope. The vehicle mount kit, which is exactly the same as our other 8000 series vehicle mounts for surface scanning. And several different brackets that better suit it for indoor stockpile or even silos. And we've also got a few other options that help you better position the scanner into the coordinate system. So one of the key strengths about the entire Eyesight line of products, and we've tried to stay true to that with our 8200, is versatility. All of our products, we really try to make them so that they can do more than just one thing. And operator safety. The entire basis behind laser scanning is remote sensing. You don't have to actually get up next to the item that you're trying to receive data from. And obviously here at Eyesight we're quite proud of our improved workflow. From field to finish, everything is incredibly user-friendly. It's very intuitive software, and the scanners are the same. They're very easy to use in the field, and very user-friendly, very robust. These are meant to be used in the field. You definitely can take them into wet conditions and into dusty areas and actually use them without worrying that they're going to break. And you can actually get more detailed point clouds for more accurate, detailed models. We have increased the accuracy to 8 millimeters. So let's take this opportunity to jump into the software and take a look at a few items here. So I'm going to start by bringing in some drift scans and show some of the new tools that have been added to better model drifts. So here you can see 4 distinct scans that were scanned from an underground mine. I've colored them all separately so you can easily identify them. And I'm going to change the view here a little bit so we can actually look at them from inside the drift. So a few things jump out right away. One, you've got this venting up top. You've also got vehicles in here. You've got pipes and other things. All the sorts of things you'd expect to see in a drift but don't necessarily want in your model. So we need to find a way that we can actually exclude these items from the surface or the triangulation that we're trying to create. But obviously with a line of sight laser scanner, you're going to pick up points on those. So in the past this would have been quite a tedious task to filter all of these out. But we've come up with some, the guys have really developed some really cool tools, including this new filtering option on our loop wrap, which allows us to actually get rid of those. So I'm going to go ahead and just do a quick filter on this data and trim it down a little bit. All right, so you can see we still have quite a few points to work with. We haven't really lost any of the integrity of the area itself, but this will allow everything to move just a little bit quicker. So I'm going to start by creating the loop wrap. And now initially there's a few changes for those of you that are familiar with our loop wrap tool. One, rather than actually having to list or having it be a preset 5 degrees where it measures each point, you can now actually specifically define how many points per loop you want, which is exactly how many nodes are going to be on the actual polygon that goes around the scan data. And you can also predefine loop spacing. So I've got my points per loop at 72, roughly a point every 5 degrees, my loop spacing at a foot. And now there's this new filter obstacles option, which you can see is checked off. And that's what I was talking about, where we can actually allow the software to exclude those obstructions for us and get a more accurate model much, much quicker. So I'm going to start on this end over here. And I'm just going to select an area. I'm going to go ahead and create a single loop. Then I'm going to work my way down a little bit, select another section, and now when I select multi-loops, it's going to go ahead and apply those preset parameters, 72 points per loop, and a loop every foot, and it's going to fill in across that area. And I'm going to go ahead and just work my way around this corner. And so now that I've already got that single loop selected, I can just continue to create multiple loops as we go until I change orientation. And then we're going to just go ahead and jump past this drift intersection here. And I'm going to go a little bit further down, and then I'll show you how we're going to take care of these intersections where the drifts actually take off in a separate direction. All right. So as I mentioned, you will need to do another single loop when you change orientation. Let's see here. Perfect. So go ahead and select one right there, and we'll do a single loop. And then I'm going to make sure that I go over the area that we did with the other drift going in the opposite direction. And I'll do the same thing down here, starting at the end, creating a single, and then making sure I get some overlapping data there. Perfect. So now all of these loops are all saved into our CAD object. And you can see when you hit this drop down, it's actually an object per individual loop. So you can click through and use all of them, but I'm just going to simply highlight all of these, not everything, just the loops. And then I'm going to go ahead and model a loop triangulation. So now this gives us a new option here as well, which is iterative. And what that means is in the past it's always forced you to do a straight loop triangulation, which in a lot of instances is fine. It's absolutely okay to use. But in this instance, where you've got curves and bends and things like that, iterative actually allows it to look at each loop separately. Rather than a preset orientation that the triangulation is going to be created from, it actually recalculates the orientation after connecting to each individual loop. Basically, in layman's terms, just makes it model the corners that much smoother. So we'll go ahead and model that. And now I'm going to bring those surfaces in. So it goes ahead and it creates a separate triangulation for each one of those multi-loop wrap containers. And let's bring those into the viewer. See what those look like. I'm going to color those separately so you can easily see what we've got going on. So, and let's zoom in here. Check this out. So you can see there's ends on these on this blue one because I allowed it to go past the intersection, and that is absolutely not what it looks like. That's hideous. We want to get rid of that right away. So I'm going to select my facet selection tool and just make sure that I'm only working with this one. And this is how I'm going to join these together. So I'm going to make sure that I just delete all of those there. Make sure I don't leave any overlapping data. Perfect. And we'll do the same thing down here. All right. So now I've got that little bit of a gap there, and I'm going to need to clean that up. So I'm going to go ahead and actually loop triangulate those together, and all that does is create more. So now I've got 5 of them, but if we come in here and take a look at these, you can see that now they've actually been joined together. There's not a wall there in the middle. This is much more accurate, but we've got 5 triangulations for an area where we should only have 1. So we've got this edit close option, or the hotkey for that being Alt-S. It becomes something that you're using quite often. And now when we go into our surfaces, we've got this joined surface. So what the software did for us is it took all of those triangulations, it closed off the ends. I'll actually go ahead and trim this end off here so we can take a better look at it and change our view a little bit. There you go. So, and I'll go ahead and throw the scans in here on top of it. So you can see the triangulation accurately modeled around the outsides. It interpreted right across the top of where that ventilation was, and it didn't use any of the points that were collected on the vehicles, the bracketing, the piping, all of that stuff. So we saved ourselves probably a lot of hours and a whole lot of headaches of processing. So that's one of the really cool tools we've added. And one of the other applications we were talking about is stope surveys. So I'm going to go ahead and bring that up now. We can take a look at that. Bring one of our stopes into the view here. So this is a scan that was taken from our 8200 on the boom mount. And the vehicle just merely backed up to the edge. And then this hole right here is actually where the cave mouth, or the mouth to the stope was. So it was extended into the middle, and go ahead and swap that view again so we can actually look at the inside here. So you can see the amount of data. You're able to, easily see the different facets of all the rocks and everything, and there is quite a bit of points here. So I'm going to quickly simplify this down just for the purpose of having a more manageable size of a triangulation. So I'll go ahead and do a quick minimum separation here. So you can see I've limited my points down quite a bit, but the overall shape and the integrity of the stope itself is still quite intact. This is just going to leave me with a much more manageable triangulation size for exporting this later on. Now I'm going to bring up the spherical triangulation tool. So you'll notice there's something new here. Originally, where it used to just be surface. And for those of you that are familiar with this, you have to actually create a look point, which again in open pit applications was never really an issue. You would just point it in the direction that you were looking at the wall when you took the scan. Obviously now we're looking to create a closed solid, so we don't want to have to create a look to point. That would actually require creating multiple triangulations and then fusing them together. So we've got this closed solid option, and then rather than actually forcing the software to look at the data from a specific orientation, it actually just looks at all of the points from the orientation of the scanner itself. So rather than an arrow, you just see this ball floating where the scanner was during the scan. I'm going to go ahead and model that triangulation up and bring that into view. So we've got this spherical triangulation here. And now we've got a fully closed triangulation of that stope. And we can still utilize all of the other tools in the software to clean this up a bit. So like down here you may notice there's some spikes and points from just some of the more jagged rocks. And just to make this a little bit cleaner, I'm going to go ahead and run a D-spike on this. And that's going to go through just like it does with the open pit data and remove spikes. So it's looking at several different things. It's looking at how many points were used to actually create each individual facet and how long and sharp those facets are and how far they are in between the rest of the triangulation. So now we've got this smooth, solid triangulation that we're able to use for volumetrics. And one of the big things for getting this into your mine planning software is ensuring that you have a valid triangulation. I want to make sure it's watertight so that it can actually be used for all of these volumetrics and comparing it to the design. So we can quickly query the surface validity. And what this is going to do is it's going to run a quick report. It's going to check for a few things. It's going to check for inconsistent surfaces. It's going to make sure it's completely closed, which we want since this is a solid and it's not an actual surface. And it's going to check for self-intersections, which obviously create a huge issue. And we can actually export these test failures. So what that's going to do is for any one of these issues, it's going to create a CAD object so I can actually bring it into the view, locate where the issue is, and do any additional filtering necessary to create a valid surface. So let's go ahead and let that report run. I'm going to zoom in a little bit on the text down here at the bottom. That's where the report's going to be kicked out. Make that a little bit easier for everyone to see. So in this instance, it passed. It's going to give you a pass or fail for all of these. And again, had it failed, it would actually give us an object for each of those failures. And it would actually create a small polygon. And so we could bring those into the view and locate those. So those are just a few of the new tools that we've added, and some specifically useful when utilizing the 8200. Obviously, as with all triangulations within iSight, you can easily export these out. They default right to a Vulkan triangulation file, and you can take this into Vulkan and have a completely accurate and up-to-date mine model for your underground mine. So there's definitely more here, and I'd like to have you guys join us on another day. We'll go through a little bit more of it. I appreciate everybody coming in today, and I'm going to go ahead and open up the floor for some questions now. So if there's anything that didn't quite make sense or some more stuff you'd want to know, go ahead and write those in now, and we'll take a few now.
Great, thanks Clayton. We actually do have a few questions already. So as Clayton mentioned, you can write those questions in on the right-hand side of your screen. There's a panel there. The first question we have here is, at what range is the stated 8mm accuracy measured?
That's a very good question. So the 8mm accuracy is measured at 100 meters. And as far as vertical accuracy, the 8mm accuracy is also consistent at 200 meters, which is the maximum range of the scanner. So let me be a little bit more detailed on that maximum range. So 200 meters is actually where the range was cut off. That is not the limit of the scanner. That was actually programmed in to make it a little bit faster to to actually run it through the process and get it calibrated. So at 200 meters, you will see just as much data as you will at 100 meters. That is not the limit of the capability of the scanner. We actually programmed that in there. So 200 meters is fully usable data, and it is 8mm accuracy.
Okay, great. When is the anticipated release date for 4.1 with all these new cool tools?
That is a great question. 4.1 was actually just released, and there were a few errors we've noticed with some Quadro card graphics. So just to be sure everyone with Quadro cards know those are being fixed right now. We have 4.2 that will be being released at the end of this month, and 4.1 is available right now. If you want to, I'll throw my email up on the screen. If you'd like to send me an email and you are up to date on maintenance, I can get that to you this afternoon.
Okay, great. Is 10 meters the max boom length?
You cut out a little bit there at the end. I believe the question was, is 10 meters the maximum length of the boom? Yes, it is. 10 meters is when the carbon fiber boom is fully extended.
Okay. I wanted to comment on what Clayton said earlier about 4.1. The plan is to get 4.2 out to everybody, as he mentioned. Is that at the end of this month, Clayton?
Yes, it should be released by the end of the month, and then as soon as that is completely fixed and all of those graphics issues have been addressed, we will have those out in the mail as quickly as possible to all of our clients.
Okay, great. Next question. Can it shoot individual labeled points that show up in Envisage on the tablet?
I'm not sure I fully understand the question. You can specifically pick out individual points if you're referring to actually locating the scan based on known coordinates within the scan. So you can select an individual point and assign a coordinate to it, and it'll translate and orientate the scan based on that. If that's not the answer this person was specifically looking for, if you could clarify a little bit, I'm not sure I fully understand what you meant, and we can readdress that with some more clarification.
Okay, great. And if you'd like to, as Clayton mentioned earlier, if you'd like to email him directly with that question, that's a possibility too. So next question we have here is, are there multiple resolution settings like the 8800?
Great question. Yes, there are. So with the 200-meter max range, we have pulled out the 8 and the 16, but there are a level 1, a level 2, and a level 4, which are the same point spacing as the 8800 and the 8810. And a level 4 with underground, confinement is insanely tight point spacing. It is very high resolution.
Okay. Let's see. How long does a scan take for a typical low-res 14-foot by 14-foot by 14-foot?
So the actual distance from the scanner does not change. It does not change the actual scan time. So a low resolution, which would be a level 1, which you're still going to receive well over hundreds of thousands of points, that will be completed in roughly just over 3 minutes. I believe 3 minutes and maybe 20 seconds. So under 4 minutes for sure. I know that. It is 3 and some change, but very quickly. Like I said, we are very proud of our field to finish time.
All right. Where does the spherical triangulation look from if there is more than one scan using the closed solid option?
In that instance, you can actually create a look point, or the ideal way to ensure accuracy is to create separate spherical triangulations from each individual look point. So you model, your 3 or 4 scans separately, and then actually fuse those triangulations together. That way, all of the facets and all of the rock faces are actually being triangulated from the orientation of the scanner itself, and then there's no weird spiking or stretching of facets to close those, and then you can fuse them together quite simply.
Okay. How do you import the triangulation into Vulkan with the correct reference points?
So once the triangulation is created and you have it in the right coordinate system, so the scan is registered prior to creating the triangulation, it retains the coordinate system and it retains all of that that has it in the right spot when you export it. So those XYZ coordinates for each individual facet and point are retained within the triangulation. So it should automatically, when you bring it into Vulkan into the rest of your map, it should automatically be right where it's supposed to be in real time, in real space.
Okay. How do you locate or survey in the scanner position, especially when it's out on a stope?
That's a great question. So I'm going to bring up a different picture here that actually shows how we do that with one of our options. So you have several options. One is this T-bar, which is one of the options that comes with the scanner. And let me bring that up a little bit. So there's these 3 brass reflector points, and you shoot those in with the total station. And then this is actually, it's specifically designed to automatically register. There is a T-bar registration algorithm within the software. The other option is to utilize our global registration, where you actually register the point clouds to each other and register the stope survey to the scan at the stope mouth. And then the scan at the stope mouth will be registered based on either known points on the wall being a prism, or you can use a total station to locate the tripod prior to setting up the scanner or afterwards, as long as the tripod hasn't moved.
Okay. When the boom is fully extended, will the scanner move as it's scanning?
It will not. It is very sturdy. As soon as you get it actually fully extended, the weight of the scanner actually settles it quite quickly, and the scanner is perfectly balanced, so that as that top piece is rotating around to complete a 360-degree scan, there is actually no weight shift. So it is completely stable. Just ensure that you don't bump the boom or anything like that while you're scanning.
Okay, and regarding that comment, how long is the boom?
So the boom, when fully extended, is 10 meters, and that is at full extension. There are obviously a couple of pieces to it, and I can kind of show that picture again. And you don't need to have it fully extended every time. So if 10 meters is more than you need to stick it out into the stope, you can simply leave one of these extensions collapsed and locked into place. If you want to deal with a little bit more maneuverable or smaller boom for whatever specific scan you're trying to get.
Okay. And can the scanner be used for convergence studies and or shotcrete thickness studies?
Absolutely. So all of the surface comparison tools that are utilized for movement detection, settling, comparing thickness by actually coloring one triangulation from its distance to another that we utilize in the open pit tools, all of those translate directly into 8200 scans for underground. So we have used them to monitor shotcrete thickness and actually create colorized 3D reports with a legend. And you can definitely, once the scan is registered, comparing it to prior registered scans, you can check for settling or convergence as well.
Okay, can you clarify the maximum operating conditions? You mentioned wet and dusty conditions.
So the operating conditions, let's see here, I think I may have had a slide that went through that, and I may be thinking of a different presentation. So when I talk about wet and dusty conditions, the scanner, like all of the eyesight scanners, yeah, that was a different slide. It is IP65 rated. So what that means is that it is water resistant and dust proof. So it is sealed tight. You can scan in very dusty conditions, and rest assured that none of that dust is actually going to seep into the scanner itself. And it can be, you can scan in rain. Obviously, if you're underground, it should be raining. But the IP65 means that it is water resistant. You can scan in rain. You can scan while it's being sprayed with a hose. The only thing you can't do is actually submerge the scanner itself. So when I talk about it being pretty resilient and very tough and rugged, I mean that it can be very cold, very hot, very dusty, very wet, and it's not going to affect the scanner's performance, and it's not going to seep into it and actually degrade the product itself.
Can you provide an estimate of the total time from surveying in the T-bar to completing a low-resolution scan?
So once the boom is extended and the scanner is in the position that you're going to be scanning from, you simply take 3 shots with your total station. Depending on the user, that could probably take 2 or 3 minutes, and then the scanner is completely wireless, so you just wait till it's out there. Obviously, turn it on before you extend it, and then from that point, you just simply select 360, hit a 1-minute scan. Typically, with turning it on, getting the boom extended, getting it surveyed in, I would say all that can be completed in under 10 minutes.
Okay, we are nearing the end of our time, but we have one more question here we're going to take. It is, we use a CALS scanner that we deploy down in the hole to scan voids. How can we set the scanner location to use the new spherical triangulation using the scanner location?
So the scanner location is actually information that is embedded within the scan file of the iSight scanner. I am not very familiar with the Optec CALS unit. I don't know if that is something that they have included. If so, then it should be embedded within the file, and you should be able to actually select within the software, and I can bring this up right now. So this is something that someone can test. When you have it in the view, bring the stope scan back in here, and then you actually go to create a spherical triangulation and you have a closed solid, you should be able to right-click on the spherical origin point and select the origin of the scan. If that's not there, then that is just something that they have chosen not to embed within the scan file. So, but if it is, then that's exactly how it picks it. It utilizes that 0 point from where the laser was being fired.
Okay, great. So if you asked a question and we were unable to get to it, please feel free to email Clayton directly at clayton.fritz@maptech.com or info@maptech.com. On behalf of the entire Maptech team, we'd like to thank you for attending today. And we hope you can join our next webinar, which is called Tips and Tricks for Multi-User Environments. That will take place on July 18th. We thank you and hope you have a great day.